Right. Now, I realize I screwed up your title yet again last time, and I promised to get it right this
I, I answer to an awful lot of things.
I
Not all
know.
of them are polite.
I know you've been called a lot of names. Let's say that. Hello and welcome to the Cloud Therapist channel. I'm Richard Simon. This is the Cloud State of Play for October 2022. Again, I have with me Paul Bevan. Paul is the Research Director of IT Infrastructure at Bloor Research. So let's say hello very quickly to Paul. Hello, Paul. How are you doing?
Hi, Richard. Great. How are you?
Not too bad, thank you. So thank you for coming back again. So for this particular month, as we always do, we pick on sort of two or three specific topics. And for this one, we've decided to go, well, first topic is going to be, where are you running your private cloud? So that's going to be an interesting question. Kind of Paul wanted to explore that. The second one is, whatever happened to PaaS? That's something I picked up on and thought we'll maybe discuss that and see the kind of the state of PaaS these days. And then the final one is called Is Public Cloud Ready for AI, ML, and HPC workloads? Right. So let's get going on those. I think there's a lot for us to go through, Paul. So where are you running your private cloud? That was something that you wanted to explore.
Yeah, when you try and sort of get this sense of how much of the workloads out there are running the public cloud or a private cloud or legacy on premises, you get this sort of story that says, hey, there's an awful lot more private cloud out there than maybe we would have thought. And so a couple of things spring to mind. Firstly is, where's everybody running it and what are the implications of running it in different locations? And the second one, which is sort of slightly more fundamental, is it really cloud? I think there's a level of that potentially going on, because if you look at, the likes of, statements coming out of Amazon and Microsoft, particularly about, how much, is public cloud, it's 20 to 30% is public cloud. And you think, well, where's the rest going? Is it all private cloud? Because when you look at some of the figures for cloud adoption, it seems to go over the top. So let's break that down. First one is actually, where are you running that? And the implications are for the IT operations people, because you can run a private cloud in a number of locations. You can give it to AWS or Microsoft or GCP or one of the other public cloud providers and let them run it for you as a private instance inside their infrastructure, which is fine, and actually that takes away from IT ops and the enterprise generally, the challenge of both managing but also acquiring the infrastructure to deal with it. So if you don't want your own infrastructure, you really don't want it, then you need to think about giving it to those people. Then quite a lot, go to the other extreme. You can run a private cloud in your own enterprise data center. You've got all the issues of provisioning, procurement, provisioning, and management of that environment. And is it genuinely, this is where I sometimes get an issue with, when you see all the stats for the amount of private cloud out there, is it genuinely a cloud in the sense that you and I would understand cloud in terms of, scaling, automation, provisioning, all those sort of issues, charging, for use base. Is it really genuine cloud? And I suspect quite a lot of it isn't what I would call it. It's probably virtualization, to various levels of virtualization, but is it genuine private cloud? I don't know. But that's a decision you can make. And certainly the likes of HP and Dell and others will help you in that process if you want to do that, because they'll put kit on the floor, as it were, Green Lake, or using Dell's environment, which you can sort of pay for as you use. But it's sometimes it's a little bit of a financial juggling act rather than a real, automated, just provision as and when you need it approach. So it's a decision. You can have it, but a virtualized environment. The question is, do you then charge your end user properly for that on an as-used basis, so that the IT department becomes a profit center in its own right. So again, I question, but that's the sort of decision you have to make. The second one, with the one in the middle between the sort of handing it all to the public cloud providers to run as a private instance on their infrastructure, is to use co-location. And I think quite a lot of it has gone to co-location. And if you tie that back to the desire of enterprises to get out of running their own data centers, quite a lot of that existing infrastructure and maybe some of the private clouds are moving into co-location. And why are they moving into co-location? Well, it's simple, I don't have the physical cost of the data center, but you've still got all the costs of running it.
Yeah.
You've got all the costs of managing, provisioning, all those sort of things, because colo is just a warehouse for it, with the best one in the world. Sure, you go to an Equinix data center and it's an interconnect hub. It's a network hub rather than just a warehouse for servers. But that's the question. Or you can get a managed service provider. And there's an interesting question about what happens to all the old MSPs and ISVs out there. What's happened to them? They've got a role to play with their customers to help them into this world and actually provide some of that, cloud facility. So I think that's as much as anything else was, where's it happening and how much is genuine cloud? Again, we get lazy with the term, don't we? And at Bloor, whether you call it lazy or we've just sort of, said we can't be keeping the waters back all the time, is that, we view cloud as a consumption model. And if you view it as a consumption model, you maybe, go away from the old, specific view of what cloud actually is, because people will make old-fashioned hosting into a cloud solution. I think an awful lot of people are doing that. They're using hosting and using the term cloud. So that's why I'm just curious. And at Bloor, we've been looking at how do we start to do some qualitative primary research around some of these questions, because obviously there's the guys like IDC and various others that do huge amounts of quantitative research, and I keep running into the problem of actually what's happening out there, because it's quite difficult to get the granularity of what's happening, and you see individual bits of research that lead you, and so at the moment I'm sort of pulling research together from so many different sources and trying to define and glean from that what's actually going on in the market. So I think there's a long way to go before real cloud adoption becomes the majority of what's going on out there in terms of IT processing, data processing, and you go to Google and you go to others, they would admit that. They say, we're only at about 20 to 30% of available, they think they've got a long way to go.
Sure. And I guess this space has maybe somewhat been neglected. It's mentioned in passing when people are kind of talking about cloud, and they say it's kind of private cloud, hybrid cloud, multi-cloud, public cloud, but actually, what is it? Is anybody doing any private cloud? And in private cloud, we're talking about actual private cloud, not a hybrid solution or something, just actually running something in a sort of a cloud environment, whatever that cloud environment is, and we'll come back to that maybe in a minute, but it's actually a private cloud of some kind. And then perhaps you look at so that's kind of setting the scene, but then you maybe say, okay, so where actually is it physically? Is it actually back in your data center and you're just kind of doing a private cloud? Is it, as you said, in kind of an MSP colo type of place? Have you lobbed it over the fence into, for the public cloud providers to kind of run it for you? Maybe there's a small percentage doing that. So location would be kind of one thing maybe to ask about, sort of where is your private cloud? And then the other one could be, what type of private cloud is it, that you run? What is the platform? Is it still, good old VMware? Is it OpenStack? Do you actually call your, Nutanix HCI, a private cloud, for example? Or do you call VMware's SDDC, software defined data center, kind of your private cloud? Or is it actually one of the new, the hot shots of the cloud service providers, the Azure Stack, the AWS Outposts, or even EKS Anywhere from AWS, or Google Anthos or something like that,
Yeah. Yeah.
right? So there's kind of maybe the location, and then maybe what type of actual platform is it, and then maybe what workloads as a third thing that you're running on it.
Yeah, I delve a bit deeper, I think, into say, what outcome are you giving your users? When you go to public cloud, the relationship is between the IT department and the public cloud in terms of how much.
It's fairly clear. Yeah.
It's fairly clear, albeit they're quite complex pricing models, but that's a different question.
That's a different question.
Different question. When you come to a private cloud, the debate then becomes the IT department is effectively the AWS in this debate, and the end user, i.e. a business department or a business user, was the old IT department in the old debate. So what do they see? Are they seeing they're only getting charged for when their application runs? Is it flexible enough that the end user can be charged per usage on a per second, per minute, per whatever it is basis?
Yeah.
Number one. Then if the user then says, I need to scale this, I've got peaks and troughs and God knows what, and can they do it? And there you talk about, what does HP or Lenovo or Dell put on the floor, and how do they construct the relationship that says, if an end user suddenly says, hey, we've got a promotion coming up and my throughput's going to go up by 50, 60%, can you provision me more servers tomorrow or next week? And they go, it's going to take 3 months. You go, well, that's no good. That's not a private cloud. It's those sort of challenges. Hey, have you got a chargeback mechanism? Can you provision or could an end user provision it rather than you have to go to the IT department? All those sort of questions. I suspect in many cases it won't be a clear-cut answer.
I can agree with that. I mean, I can certainly speak from experience on some of that. This is not obviously the solution that everybody was necessarily implementing five to 10 years ago, but certainly in some of the roles that I've done in the past, OpenStack, for example, was designed to be that. So it did have a chargeback module.
Yeah.
It did have for all intents and purposes, an observability module. It had a auto provisioning sort of capability as well. I think what's happened is that some of those aspects, and never mind, as you just pointed out, never mind the management of that, the managing, updating, patching, securing, etc. So the maintenance aspect of it, the management aspect of a platform like OpenStack, which is a job in itself.
Yeah.
But the growth, the scalability aspect of it was all supposed to be in there. But how, as you said, how well is that being done? And are we actually maximizing that capability? Can we do that? If you come to me, as I'm IT and you're you're marketing or sales or whatever, and you have this campaign, as you said, can I scale you up by tomorrow or 48 hours? Can I scale up your service for you? Even though I am running OpenStack, and OpenStack should know or should facilitate that capability and make that capability a little bit better, a little bit faster, a little bit easier to do. So certainly, I think in answer to some of your questions, OpenStack, for example, was designed to that. I'm sure, HCI and SDDC and so on were all also kind of geared to for that capability, to actually offer you that sort of capability. And let's not forget that actually went on, even further. We started having things like, Mesos, for example, kind of the server operating system, so-called server, or, platforms like OpenShift or Pivotal, or even just kind of Kubernetes distributions, really.
Yeah, but the point is, and I think this is the sort of point it comes back down to, which is a bit sort of prosaic in one sense, is that whatever cloud you're using, however many of the tools you're using, however fluffy that cloud is, somewhere down the line, all that data, all those transactions hit a server, hit a switch, hit a storage array. Physically it's still there. So if you hand it over to AWS or Azure or GCP, you're going, well, they've got the scale, and obviously it's their issue about how they deal with that. If I do it in my data center, or even if I use a colo, I've got to think about how I do that. Can I afford to do that? Will my vendors who I work with, help me achieve that in some sort of way with some sort of financial arrangement? But it usually gets quite messy. It's not as clear cut as, I just charge them for a transaction. I don't have to worry about it. And when they suddenly need more, it bursts. Yeah, I haven't got it on the floor. How quickly can Dell get me another server? Those sort of questions. Dell can put it on the ground and they're going to say, yeah, but am I going to leave a server that you're not paying for 300 days of the year and 65 days of the year you actually need the extra word? You just want to pay for it on a transaction basis. So it becomes a different financial discussion. Is that genuine cloud? It's back to my original question. And therefore, are we kidding ourselves that the world has gone completely cloudy? I mean, there's a different discussion around cloud, which is, about the development tools and how you're developing those applications, and back to something you said. But I think there's a real sort of danger that we get into this, hey, I've got a private cloud. And it's what you might tell your senior business leaders. Hey, it's all right, don't worry, we're in the cloud. A bit like telling them that you're doing DevOps, and actually the reality is that 80% of your time you're trying to manage the legacy environment. And everybody at the top thinks, hey, we've got a private cloud, hey, we're doing DevOps. And when you get down to the guts of it, they're not doing that.
Yeah,
it's more realistic than getting a little starry-eyed about private cloud.
Yeah, no, I can appreciate that, and I think yes, it's in a fair proportion, I would say, is certainly I think that's certainly evident and certainly the reality for a fair portion of kind of what we would quote unquote call cloud, sort of stuff. So I do agree with that. I think the private cloud, really private cloud, whatever that happens to be, wherever it is, whatever it's running and whatever the purpose is, has somewhat been overtaken by hybrid cloud. No sooner did we kind of catch our breath on what cloud is and private cloud means, did the hybrid cloud come along, because the public cloud provider said, well, we can't have this kind of disconnect between your private cloud and our public cloud, so we need something that will connect the two. And then the excitement kind of started around hybrid cloud. So maybe some of it has kind of been somewhat overtaken, I think, and sort of overshadowed by sort of the advent of hybrid cloud.
Yeah, but I back to my original point. If you've got applications, data, networks that are reliant on or not reliant on AWS or GCP or Azure or one of the other public cloud providers, you've still got all the challenges of provisioning, you've still got all the challenges of management, and the likelihood of it being genuinely cloudy, if I can use that term, is probably pretty rare. And so it's just, we're sort of in danger of kidding ourselves that we're moved farther and faster into a cloud world than we actually have. Not that you and I shouldn't be talking about all the latest developments in cloud. We've had this discussion before, and absolutely should, because you're trying to drag everybody along behind us, in the sense of getting them to do it. But the reality is, you've got to find, when you look at the research that says, how many of the people who say they're using multi-cloud or hybrid cloud have got more than the odd application that uses that sort of capability? They might be using multiple clouds because actually a particular application runs better under GCP than it does on AWS or Azure. But have they connected, those three together? I mean, okay, we talk about Kubernetes and EKS Anywhere and starting to make it viable, but actually on the ground, it's still quite new.
Yeah, perhaps maybe we need a chart for this, maybe like a graph. One end where we're still kind of in the quagmire of the data center and all these sort of old legacy workloads and monolithic apps is kind of quite thick, and then it kind of thins out as we go more towards sort of public cloud and, serverless and all the kind of, all the latest stuff.
On the flip side, let's take a more positive sort of cloud view, is one of the questions I've sort of posed is most new development cloud-based? And I think the answer to that is very different than whereas my existing system's running, because they've been running for years and years and years and years, and how do I move them and all those. But when people are building new applications, I think the vast bulk of them now are being built with the cloud in mind. They're using the tools, they're using the environments, they're running them in a cloud environment. And this is where the hybrid cloud comes in, isn't it? You've got a new application, you put it into AWS, you do need to make that link back to data maybe that's part of a system of record. Absolutely. So there's a sort of sense that these two worlds, where there are new applications, and to be, they're being done in a cloud way. And to be fair to the likes of an IBM or a Unisys or whatever that have got real old legacy mainframes, they've done a lot of work to ensure that it's easy to make those links, to provide the tool sets that run in their environments. So I think, you can take a much more positive view that says new applicant, but of course you've broken the new applications up into such small component parts, microservices, containerized, function as a service, all those sort of things. Says it's not like applications were in the old days. You can't make a direct comparison, but most new development is going in a cloud environment. I think would be a way of saying it. But there's still an awful lot of that old stuff sitting on in a different world that will be there for many years to come.
Yeah, so at least cloud aware, if not cloud native, so to speak.
Correct.
And I think we can probably go on the whole session for
this. I know.
Talking about this one. So
we'll go round in a loop in a minute if we're not careful.
Yeah. Right. So let's move on that note. Let's move on to the second one, which was second topic, which was whatever happened to PaaS. Now, the thing for me is, and again, being a kind of a slight historian of and a slight sort of student of the IT industry, PaaS used to be kind of platform as a service was a product in itself, and I certainly worked for at least two vendors at that point where they actually brought out a PaaS product. So you actually had a product that was PaaS, and it had all sorts of stuff in it, and then almost on top of that we had the advent of containers. So you actually saw container, and then at that point it became a decision for vendors. Do we put the container stuff that we're sort of working on, so both the kind of the Docker side and then eventually the Kubernetes side, into the same platform, or do we actually productize them separately? So we have one which is about the platform, so you got Docker and Kubernetes on one side, and then the other one is just the good old PaaS continuing. Now some vendors decided to go the separate products routes, and then some other vendors actually decided to put it all together. And on that note, you only need to look at the history and the version numbers of or versions of Red Hat's OpenShift, for example, to see that it started life as a PaaS platform. But then with the advent of Docker and and Kubernetes and so on, that got added in there. And then with the advent of things like DevOps and whatever, all the tools for that got added in there. And I sort of remember, having Jenkins in there and stuff like that, I believe, and then it's kind of, they finally removed it and put something else in. But the point is that the DevOps sort of stuff came in there, and that got added to it, and so on. And it's kind of just been really developed, and I suspect next is going to have a bit of GitOps thrown in as well, with version 5 or 6 or whatever it's on now. So they decided to kind of go with the amalgam, with everything in one platform. It's called OpenShift, and you use it for different things. If you want it to be a hosting platform, you use the Kubernetes aspect of it. If you want to use, I don't know, some libraries and modules and database service or whatever, then you kind of lean more on the PaaS side of it as a developer. And if you want to do other stuff that's related to the kind of the containerization and things like that, then you lean on that aspect. So there's all different types of parts of it that are for different things, and obviously DevOps for kind of development. So I saw that sort of with Red Hat's OpenShift. Like I said, some of the other vendors that I worked for, they kind of broke things up. They were kind of running in separate sort of platforms. And obviously then you had the advent of the hyperscalers really kind of coming in, offering things like database as a service. So that kind of maybe took away a little bit from what PaaS used to do, and what the likes of Pivotal, for example, is kind of an amalgam of the VMware Dell EMC sort of alliance, I believe, and where they made their money, basically, where they and their breads was on PaaS using Cloud Foundry, which is one of the sort of major PaaS platforms at the time. And you had IBM, you had VMware, had all these players in that camp, and then you had Red Hat, I believe, with OpenShift in a separate camp. But I think what PaaS used to do is kind of somewhat dissipated or been sort of added into and amalgamated into some of these DevOps platforms, into some of these sort of infrastructure platforms, and so on. So nobody's really kind of saying, "Hey, here's a PaaS platform." I mean, even Pivotal, which, like I said, that was their version of Cloud Foundry was kind of the core product, the core solution that they offered. Is now, I think, Tanzu application service. So it's kind of in a bigger, the kind of the bigger Tanzu tent, so to speak.
So yeah, it's changed like everything else. It's morphed into something slightly different. I think if you think about what was the purpose of the PaaS in the first place, which was obviously this sort of abstraction, again, to make it easier for developers to develop applications without having to worry about the underlying infrastructure. That's effectively what was going on. And it was tools. And of course, you're always up against that age-old debate that says, how do you offset performance, price performance, and ease of use and ease of development for people who haven't got the time, and energy to research the latest, greatest tool that they can stitch together themselves. So you're always going to make those sort of compromises, I think, in terms of, which way do I go? Lock-in is a one of the things you have to think about. Price performance is another one, but there's the simplicity and ease of use all came into play. And I think, PaaS hasn't gone away. I mean, if you look at most of the stats that are out there, there is still quite a large segment that's PaaS. It's, if you take the three mains as a service constructs, infrastructure as a service, platform as a service, PaaS, and SaaS, software as a service, PaaS is the smallest, and always has been the smallest, but it's still growing. Now, whether I agree with you, I think, it's morphed into something that you wouldn't necessarily recognize from the past. I mean, what I'm seeing is far more specialist PaaS coming out. There's one at the moment I'm looking at, which is for high frequency trading. Now, you'd have thought, my goodness me, would you put a PaaS for high frequency trading, given that it's such a handcrafted, hand-stitched environment to make the absolute performance? And yet, actually, yes, they are starting to look at that, for various reasons, without going into it. And you start seeing PaaS for quite specific use cases, whether it's, you're getting PaaS in the IoT space, because of the challenges of putting together, trying to get a simple set of APIs, if you like, that developers can develop to. And it's been a mishmash. So again, it's that interface layer. So I think it's changed. It's still there. Are they more flexible at dropping in the latest, greatest component? But I think that's what's happened. So I don't think anybody's branding them as a product per se
anymore.
I don't think, they're there. They haven't gone away, because you've still got that differential, that layer of abstraction, so the developers can get on and do their work without having to worry about what goes on underneath. It's still there, but it changes so rapidly that, OpenShift, it's a bit like, having your own foundry for chip design and development. It got too expensive and too difficult, and you couldn't really compete with all the changes going on unless you had that huge scale that the Taiwanese have got, TSMC has got. You can't do it. Becomes exactly the same issue here, that a VMware or an IBM open Red Hat just cannot keep up with all the changes going on. It's how the heck, but you still need that abstraction layer between the two. And of course, there's a different question. So let me just throw in another one just to complicate matters further.
Go on.
Serverless. What's the difference between PaaS and serverless? I could think there are differences, but the intent's the same, isn't it? The intent is to enable developers to develop without having to worry about what the underlying infrastructure is.
Yeah, so that takes me to what I just kind of hinted on earlier, and that some of the things that we maybe used in one of those products, so OpenShift or whatever the other vendors kind of provided that was based on Cloud Foundry as a PaaS, is now offered, almost as you could call it a kind of a public cloud PaaS, or you could even call it a SaaS in the public cloud, that you can just consume now. So and a typical example of that would be like a database capability. So whether your PaaS previously actually offered you PostgreSQL or whatever open source database you could use, whether it just facilitated your application talking to a database, so it kind of did the libraries and modules, whatever it is, API requirement that allowed your database to talk to that type of database. That's not that relevant, but the point is that whatever that PaaS platform used to give you is now essentially as available as a consumption model via consumption model in the public cloud. So kind of the cloud service providers kind of taken some of that sort of stuff that used to be in PaaS and just offer it as a SaaS solution now. It's like a database as a service type of thing.
Yeah, I would say that database as a service is SaaS, not a PaaS.
Yeah.
Because actually the whole point of the PaaS is that you abstract away from the underlying stuff, whether it's a database or whether it's a piece of hardware infrastructure, and you then enable people to plug different ones in. I mean, you use APIs and API gateways or whatever the connectivity methods are to say, actually, I don't want to use Postgres. I want to use, they might want to use a different type of database altogether. We're seeing a lot of people starting to look at graph databases now and time series databases. So the world's got far more complex, and you could deliver those as that's a SaaS.
I'm just kind of looking at it from what the function kind of PaaS used to be, and it was to facilitate those types of things. And as we said, we don't really care what the database at the other end is, as long as it's a database. And some of them, I believe, used to offer that. I could be wrong. So again, viewers, correct me on that in the comments. But some of them used to kind of offer specific ones, and some of them, as you said, we API'd into that, and we abstracted that, and then whatever the database was, we didn't really care as a PaaS user. But what I'm seeing is that model where PaaS was a product in itself, so OpenShift, Pivotal, and so on, is not really now at the forefront. It's DevOps is the forefront, and maybe the PaaS elements are somewhere in the background of that type of platform. So again, OpenShift and Pivotal, I think, are examples, of that sort of progress that's kind of happened to PaaS. So we're no longer kind of talking really PaaS anymore. Maybe the developers do at their level when they're developing code or something, but it's more a DevOps platform now. I think it's kind of matured and become part of a DevOps platform. And then other elements of it have been taken away and put into the public cloud, so you consume them as their PaaS or their SaaS, if you like.
Yeah, maybe this is a maturity thing that says as you become more mature in a particular environment, you morph into that direction. Hence why we're seeing like in the IoT space, like in sort of, that very specific use case for around high frequency trading, where you're thinking, actually, these are immature in the sense that either there's no standards out there for how the hell do you help the developers develop something when there's no standards to work on, and you put the paths in between the two to take away the pain, or you get hold on a minute, handcrafting high frequency trading systems in this day and age surely is crazy. Can't we do something else about that? And how do you put a PAS in place that takes away the pain of having to handcraft those bits? And again, so you're seeing, maybe it's just a maturity. I mean, the first time I'm, having this discussion, I think actually it's a maturity curve that says the whole development environment has become more mature in the way in which it uses that interface between their application and the hardware. And hence, serverless is just another variety of that.
Yeah, I mean, the certainly it was certainly a product. We certainly saw, vendors coalescing around, Cloud Foundry on one side and Red Hat on the other side with OpenShift. OpenShift certainly started life as a PaaS platform by a company, I think, Makara or something, that Red Hat acquired, and it was, definitely a PaaS platform. But as we said later on, what we saw historically, that Red Hat decided to put everything, all the other advents, so DevOps, containers, orchestration with Kubernetes and so on, all in one platform, whereas other vendors kind of wanted to continue separate licenses, separate subscriptions for all of those sort of solutions. And then we're seeing, like I said, sort of maybe now we're seeing the likes of Pivotals kind of renamed as part of the Tanzu tent for VMware, so it's now Tanzu Application Service, I believe. I think it went through a number of iterations. So I was part of that sort of time when it was going through. When I worked at Heptio, we were actually offering our Heptio Kubernetes service, HKS service, as part of the solution for Pivotal. So it kind of got bundled in all sorts of unholy packages at that point. But that's I think all kind of moved on now. So it was just really interesting to explore what's happened to PaaS. It seems to kind of, sort of maybe absorbed by DevOps or something.
Yeah, I think as much as anything else, you're back to this. If you want the freedom to use whatever tool you want from a developer's point of view, whatever application environment you want to use, and you're talking about PaaS, the two sort of come into conflict, don't they? Because PaaS, by just the nature as a service, suggests that there's a fixed, boundary around it. It says you're going to use this, and this for that to work. And of course, you come up against a developer environment that's going, hey, we've got complete freedom these days. Okay, guys, really? And you have that sort of, all right, okay, I hear you. But if you're doing that, the level of complexity you're going to bring into the middleware layer is going to be so huge. That you're just shifting the cost and the complexity around somewhere. So you make that compromise. But I agree. I think it's just got more mature to the point where it's less of a one size fits all PaaS as to a platform, a much more flexible platform that you can plug in a lot of different things to, and therefore you can't really sell that as a product.
It'll be interesting to maybe we can revisit it again sometime and just kind of see where it's at in a while. Okay, so let's move on to the third topic, which is public cloud ready for AI, ML, and HPC or high performance computing workloads?
Interesting one, in the sense that clearly AI and ML are being offered by the public cloud providers and various other HPC. But the reason for asking the question was, when you look at it, most of the AI and ML that you're seeing in the public cloud at the moment is the training of models rather than running AI and ML in sort of production type environments. And you have to ask the question, why? I've had some interesting discussions with people in the last few weeks around, what's the situation, what's the issue, and the things that come to place. The public cloud providers have provided, via their relationships with the chip providers, and using the various technologies they're now bringing to bear, in terms of GPUs and gate arrays and and actually being quite tuned. They've got some tremendous benchmarks out there that says, hey, we can deliver all this stuff. The one thing that they've not done, and this is where the problem seems to arise, is there's no benchmark there for the performance of the data. Because actually, when you think about it, when you're training AI and ML systems, you're using a subset of the data. You're using, you've got the metadata, and you've got fairly small data files. So the cost of there's two issues. One is data egress and ingress charges. When you do that, and in a training environment, it's not too bad. And the other is latency. How good is that connection between, and so when you look at it, you need, parallel file systems. You need real fast access to data to be able to run AI and ML systems. And again, it's just like, high frequency trading, or it's like online gaming. Latency becomes a real issue. And if the problem with latency is the data. So there's an interesting project going on from the ML Commons group, so Machine Learning Commons, where they're now looking to develop benchmarks for the actual data movement. Because in an AI and ML environment that's in production, you're going to be using much larger data sets, huge data sets, large amount of data. You have to keep shifting those into and out of clouds. A, it gets very expensive, and B, there might be a latency issue because we've got no benchmarks as to how good the various storage components of a public cloud are at dealing with this. And that's what the ML Commons, I think, is trying to get to grips with now, is having a look at storage benchmarks to say, is it such? And the other issue, and this is back to something that we're seeing a lot more of, is that in today's world, compute is moving to the data, not data moving to the compute. In the old days, you used to have to shift the data to where the compute was. Nowadays, and if you look at IoT and things that are going at the edge, the compute is moving to where the data is being generated and where the output of the data is needed. So again, you have to say, is the public cloud right for that currently? And I'm sure AWS and the others will all have very strong arguments that says it will be, and I was at a conference up in Birmingham 2 or 3 weeks ago, which was a company called InterSystems, which I come back to, but they had AWS person on stage. It was really interesting. And every time that question came up, the word outpost came out of this person's mouth. It was quite funny, and actually it's, the danger was that, outpost was the answer to everything. And I think, they hadn't quite thought through the issue of egress and ingress charges. They hadn't quite thought through of how close to the edge do you need that to be? I mean, we're starting to see ML and AI capabilities being put into processors, sensors. I mean, literally. So I mean, it's very small footprint. Are you going to be able to put that into a public cloud in the short term? The answer, I think, is no. And therefore, I like all these things. Is it ready? Is it ready for cloud? For some instances of AI and ML, particularly training, the answer is an unequivocal yes.
Right.
Then you've got to start thinking about how much is it going to cost me in a production environment to move the data required in and out, because that gets expensive, and how good is the disk subsystems, the storage subsystem in a cloud environment able to deliver the data fast enough to the processors to get the performance you actually need for real-time AI ML decisions. And that's where I think the jury is out. And I'm sure in 5 years' time we'll come back and go, yeah, they cracked that one. But at the moment, no.
Yeah, and I have to say I can't speak too intelligently in regards to that. The bits I have seen though, which I can speak to, is, for example, the public cloud providers, the hyperscalers, have provided their own silicon, for example, in GPU silicon and so on. So, for example, AWS has Graviton, and I think they're in the second or third generation, probably about to announce their fourth generation of that. So, in those sort of instances and container T-shirt sizes, they're kind of offering offering that kind of capability already. Again, it's build your own, so there's nothing there that says it's ready to go and come and use it. It's not a SaaS as such.
No.
In from the CSPs anyway, from the cloud service providers, but other vendors are offering that. So if you kind of want to crunch data and so on, you can go to Data IQ or Data EQ. I can't remember how they pronounce their name. Probably butchering it anyway. The likes of Clicks and Tableau and people like that all offer that kind of SaaS platform where you bring your data into it, and then they calculate that and apply their platform, whatever their services are, on that data. So whether it's kind of business intelligence and AI ML stuff, and so on. I wouldn't say they're necessarily HPC. That's probably much more.
And it's analytics as much as anything else.
Yeah, exactly. That's much more. Yeah, I think that's a much more kind of specific type of workload. But again, I was at the AWS Summit in London in the summer of this year, and I'm not going to quote the numbers, but they did demonstrate an HPC cluster running. I don't know how many thousands of nodes they had, but it was literally in the thousands of nodes. And they actually demonstrated that in live at the event. So there's clearly kind of capabilities there. How good they are, and again, how do they take into account data, the ingress and egress of the data and things like that. I don't know. Like I said, I can't speak smartly, around that. But I think that kind of what we were doing in the data center, using either on-prem, bare metal, or virtual machines, is kind of somewhat being eroded by things like containers, for example. So again, that maybe might bring back or might swing it sort of more towards clouds, where you're kind of using public clouds for HPC workloads and things like that in the future.
I absolutely concur that with Graviton and other developments that the hyperscalers are coming up with, from a pure processing point of view, they've got the capability to do this. There's absolutely no doubt about that. And if this work going on with ML Commons can provide a clear benchmark for data performance, the performance of, how do you access that data? What are the performance benchmarks that you need to say, yes, it's viable in the cloud? Then I think if that comes through, you go, yes, hence my statement that says, in a number of years' time, and as an analyst, you hate it when somebody says, how long before that becomes reality? Because we always get it wrong, so it doesn't matter what we do.
It's a finger in the air.
It moves too fast round us for us to be able to predict accurately what's going on. But it'll come. I don't think there's any doubt it'll come. But again, it might need the cloud providers to think about their charging model for data. If OVH was only a little less French-centric and a little less quirky about being French-centric, their free egress and ingress, no egress and ingress charges ought to put them in a very strong position. But of course, they haven't got the deep pockets of an AWS to deliver their own silicon. It's coming. I just think at the moment there is still, for a real model with large scale data files, you probably not want to do it in the cloud yet. But to train data, AI and ML models, absolutely.
Right. Well, so I think that whole space is quite fascinating. So we need to keep a close eye on it. And see how it progresses. And hopefully get a chance to maybe revisit that in the future.
Yeah, that'd be good.
Excellent. Well, Paul, we've sadly come to the end of yet another rant, our monthly rant. So really, again, appreciate all your thoughts and all your insights, as interesting as ever. Hopefully you guys have all enjoyed watching this episode as well. And and we'll see you next month.
Thank you for watching. Please consider subscribing to the channel, and we'll see you next time.
Yeah, your audio's sounding good today. I think we had kind of maybe a UFO hovering over your house last time round or something. It's like...
Purple spaceships over Yatton. Sorry, and you'll have to go and look that reference up.
Okay.
Purple spaceships over Yatton.
Right. If this ends up being one of the outtakes, then viewers go and have a check on that.